It's warm and nice. Not too warm though. Mountains. All right, so let's go to the presentation, my friends here. Okay. All right, so if you guys go to chapter 5 talks about point-to-point continuation of the point-to-point calculation, um, point-to-point calculation that we did yesterday, if you guys remember. And I know I'm throwing a lot of stuff at you, but you guys can handle it. You're big boys and girls. Point lighting calculation for horizontal surfaces. And so we're going to do the horizontal surfaces, and at the end, we're going to do it for vertical surfaces. Let me remind you what this picture that you're looking at is, guys. Yesterday, I showed you how we did calculation for, I told you when you do foot candle calculation, Karen, there are two methods. One called is the lumen or the average method, and that's easy. It only gives you the average. The other one, which is the most detailed one, is called the point-to-point method. If you're using it with visual, guys, you are right now doing point-to-point method. I walked some of you guys through the lumen method called, which is the average method. It's fast. Now we're going to continue doing the point-to-point method, except, Brian, this is for outdoor light. And the reason we're going to do it for outdoor light, then you don't have to worry about reflected lights. Guys, when you have a lighting source and you want to lit a surface, that surface will receive light, so that's called direct light, the one that comes from the fixture, the lamp, directly into the surface, that's direct light. And matte, also reflected light. So there will be a beam that comes from this, hits this wall, and right into your disc. Reflected light. This chapter, guys, does not in any way, shape, or form deal with reflected light. This is just the direct light. So here's what you're looking at. You're looking at 3 fixtures in a parking lot area. Did you guys hear me? 3 fixtures in a parking lot area. So there are no walls. There are no reflected lights to speak of, right? Because in the parking lot, what are you going to reflect from, right? Typically, there is no walls to reflect from, no ceiling. Typically, the tar is very dark and does not reflect, not a whole lot of reflection, right? So reflection is assumed to be what? Big, fat, fluffy 0. That's so all the light that you get is directly from direct light from where? From the fixture. Okay. So Kieran, I have fixture 1, fixture 2, fixture 3, and I need to do calculation at foot candle calculation at point A, point B, point C. The fixtures, everybody can see what this means. I have fixture 1, 2, and 3. I need to do calculation at point A, which is directly under 1, point B, which is directly under 2, and point C, which is directly under 3. The height of the poles that these fixtures are is 10 feet. They're 10 feet, and they're also placed 10 feet apart. Did you guys hear me? Everybody understand what we have? We have 3 poles with light at the top of them, placed 10 feet apart. And we need to find the foot candle calculation at 3 points, point A, point B, point C. The geometry is very important, guys, because you're going to be using sine and cosines. Did you guys hear me? Sine and cosines. Geometry is very important. Okay. These fixtures are 70-watt fixtures. And do me a single favor. For 75 fixture, guys, if you go to page, here we go. If you go to page 49, this is how they look when you're looking at plan view. Can you guys see that? Here's a parking lot 1, 2, 3, and there's a 4th one here that lighting that area. The photometric data that we're going to be using, Karen, is the one that I used yesterday accidentally. This one. Can you guys see that? This is on page 50. That's the photometric data that we're going to be using. Okay, so what do we need to do? We need to find the foot candle at point A, point B, point C. The formula that we're going to be using, guys, is called foot candle multiplied by CP, candela power, cosine Q, or theta, to the power 3 divided by the mounting height. I have a GF is called guarding factor. Do you remember the maintenance factor that we did yesterday, guys? Think of it as a guarding factor is like a maintenance factor, except when you have a lighting fixture outside, they put a guard on it. that guard will limit the amount of light that's coming out of it. Can you guys think of that GF like a maintenance factor? You can think of it exactly like a maintenance factor, as a matter of fact. So that's guarding factor is 0.88. And you can add a maintenance factor. Okay, so what do we need to achieve? We need to calculate at point B. Can you guys, everybody see where point B is here? Yes, no? So here's point P. I need to do a calculation for point P. Now the first thing I need to do, guys, is, let's use blue here. So I need to do from which fixture? So I'm right here. I need to do the calculation from fixture. Let's do fixture 2. I'm going to do it from fixture 2, then from fixture 1, and then from fixture 3. Do you guys agree with me that this point B here will have light coming from fixture 2, fixture 1, and fixture 3, and you add them up, that will get you the foot candle at point P from the 3 fixtures. Did you guys hear me? So for example, let me just show you an example. Right here where your mat head is, if I want to find how many foot candles right at your head, Matt, I will take the foot candle coming from fixture 1, fixture 2, fixture 3, add them up, and that will be the total foot candle right at your head at that particular point. If I want to move to Adam's head, the same thing, from fixture 1, fixture 2, fixture 3, right at your point, at your head, and the same thing for Derek, right? If I want to take the contribution from each one fixture right at your head. These are the points versus the fixture. Everybody understand that one? Cool? Okay, good. So let's go, the way you're going to handle this one, so I'm doing calculation for fit at point B. Everybody understand? So ignore C and A at this point. Point B, guys, let's do the first calculation as from fixture number 2. From fixture number 2, guys, right here, from fixture number 2 to point B, the angle between 2 and B is what? Anybody can guess the angle between 2 and B? 0. So Q, the angle here, then my Q equals 0. The angle is 0, right? My angle is 0. And if you take angle 0, guys, to Fig 5.3 page, what page is that, Chad? Page 50. Anybody can tell me what the candela power, guys, for angle 0 from Fig point 3, page 50? Anybody? Thank you, sir. 949. So that's 949 candela power, or lumen. The units for it is lumens. Lumens. Okay. So 949 lumens. Each lumens. Any comments, guys, about 949 lumens coming out of that fixture from any question about angle 0? At angle 0, the fixture will get you this amount of lumens. Very, very important. Then that's from fixture 2. Then the calculation becomes very easy. Then, guys, you're gonna go foot candle for this particular fixture. You need the guard is 0.88. Multiply this one by 949 lumens. Multiply it by cosine. What's the angle? The cosine miss 0 raised to the power 3, and divide this baby by 10 to the power 2. Divided by 10 to the power 2. Any comments, guys? Any questions about that? So what I did, I plugged in these numbers into this formula. That's a formula that you need, that we used yesterday. GF is the guard factor. CP, candela power lumens, cosine angle, the angle between the point that I need to do the calculation and the vertical, which is 0, and divided by the square of the height. If you guys do this, ladies and gentlemen, you have just got yourself a healthy 8.35 foot candle. Any comments, any questions? That's the contribution of fixture 2 at point B. Does that make sense? At point B. Contribution at point B. Okay, so that's the contribution from fixture 2 to point B. Now next, I need to go find how much foot candle coming out of fixture 1 to point B. I want to remind you, Karen, from geometry and symmetrical, can you guys see the triangles here? The symmetrical triangles between point 1 and fixture 1 and point B, and fixture 3 and point P. Can you guys see that? These are triangles. What does that mean? Means you don't need to do the calculation for fixture 3. It's identical to fixture 1. So the contribution, foot candle contribution from fixture 1 to point B is identical to the contribution of fixture 3 to point B. Okay? So let's go. I think next we're doing from fixture 1. We're going to go to fixture 1 here, all the way to B. Can you guys see this angle here? Everybody can see that angle. So I need to find this angle. To find this angle, if you take the tan, do you guys remember the tan? The function tan. Tan equals the opposite over the adjacent. From tan the angle, you can find the angle. Then from the angle, you can find the the candela power. From the candela power, you can plug it into the system, and off it goes. So let's go and do this particular one more time. So I'm going to go right here, guys, and see from fixture number 1, from fixture number 1, the angle, we're going to call my angle is Q1, guys. And to find Q1, the first thing you need to do is take tan Q1 equal 10 over 10, which is equal 1. Can you guys see that? Tan Q1 equal the opposite here. Let's go back here. Equal the, to find the tan, the opposite here over the adjacent. That's tan of an angle, right? So that's Q, that's 1. So why do I care about the tan of an angle? Because I need to find the angle. If you know the tan of an angle, you can find the angle. So gentlemen, tan inverse, and then from here, you take tan inverse 1. You guys remember how to do that? Tan inverse 1 with your beautiful calculator. If you do tan inverse 1 in your calculator, if you don't know how to do it, please let me know. I'll show you how to do tan inverse. That will get you 45 degrees. Ladies and gentlemen, my angle is 45 degrees. Can you guys see that? So from now, the goal is to find the angle. If I find the angle, the rest is history, right? Okay, so that's what we found this angle here. So I'm going to do now right in here. I'm going to go for so now Q1 equal 45 degrees. Take this one, guys, to fig. What was the fig? Fig 5.3, 5.3, page 50. From there, you're going to find that the candela power. Can you guys see that? Anybody? Adam? What did you come up with at 45? 1039. Thank you. It's 1039 lumens. 1039 lumens. Can you guys see how the process is? First, find the angle. Then from the angle, you can go find the lumens. Okay? Now, the last step is piece of cake. The last step is piece of cake. The last step, my friends, is right here, is foot candle equal. Now I'm going to go plug in 1039 times it by well, let's use the God factor first. Let's use the God factor. So I'm going to use, let me use a different color here. So 0.88, multiply this one by 1039 times cosine 45 to the power 3 Divide everything, gentlemen, by 10 to the power 2. And when you do all this, you should come up with what I think is 3.23. 3.23. Did you guys come up with foot candle? 3.23. Foot candle. 3.23. Cosine 45 raised to the power 3. Cosine 45 raised to the power 3. Any comments, man? Does it make sense? Okay. So now the contribution from fixture 1, guys, at point B is 3.23. Now the last contribution that we need to do, I want to call it here, from fixture number 3, from fixture number 3 at point B, from fixture number 3 at point B, guys, as I want to say symmetrical. And the foot candle, no need to do the foot candle. Your foot candle equal 3.23. Okay, one more time. It's symmetrical to 1. So let's look at that one. So the foot candle, guys, that's coming from 3 to B is exactly symmetrical to the triangle that's coming from 1 to B. So do I need to go do the same calculation? Did you guys hear me? If you're coming from 3 to B, is identical calculation as from 1 to B, because the symmetrical triangles give you same area, same answer. Did you guys hear me when I say symmetrical? If you can see, I don't know if I want to make it too. If you can see this triangle right here, this triangle right in here, and this, so this is coming from here, and this triangle right here, they are symmetrical triangles. When you have symmetrical triangles and you do calculation on them, you're going to end up with the same angle, the same length, everything is the same, the answer would be the same. Can you guys see the symmetrical? Yes, no? Can I have thumbs up, Chad, your piece of cake? Okay. So from fixture 3 at point B is 3.2. Then the last thing you need to do, total foot candle at point B. All the foot candle at point B. So here's what you're going to do. I'm going to take foot candle 1 plus foot candle 2 plus foot candle. This will equal foot candle 3. Cool? And if you guys do that, this will equal to foot candle 1 was 3. That was 3.23 plus foot candle 2 was 8.35 plus foot candle 3 was also 3.32. Gentlemen, you got yourself a 14.87 foot candle. Can you guys see that? The total foot candle from the 3 fixture at Matt's head, which is point B, would be adding all these 3 together. Any comments, any questions? Can you guys see that? Everybody can see that? See how easy the calculation is? Does it make sense? Does it not make sense? Now that's the calculation at point B. Well, let me remind you, again, that's why I gave you guys that graphic. Here's where we're doing all this calculation right now at this point. From 1, 2, and 3. I started with 2 because it's easier, called the nadir point. 2 right here is called the nadir point, 0 angle. And then you do the 1 and the 3 are symmetrical, so you don't need to do both of them. Same answer. Go ahead and do it if you want to. You'll end up with the same answer. Right? So the angle Q3 is 45 and angle Q1 is 45, so no need to repeat the calculation. Derek, does it make sense? When was the last time you did Greg? High school?
No.
You did. Oh, you guys did it with us too. So really not a whole lot of trig here. You're using the 10. Okay. Any comments, guys? Any questions? Any comments? Any questions? Yeah. Cosine is always the opposite, or the cosine is adjacent over the hypotenuse. Sine is the opposite over the hypotenuse. Tan is the opposite over the adjacent. Okay, so let's go ahead now to point P. I'm going to do the same calculation to point P, guys. I'm sorry, we did point P. Let's go the next one I'm doing. Which one did I did B? I'm doing A. Can you guys tell me one little thing? If I do the contribution from 1 at A, do you guys see that from 1 at A is identical to 2 at B, right? Do I need to do the calculation even? From 1 to A is identical to 2 to B. So no need, same calculation. Same fixture, same calculation, same guard. So really, you don't need to even do that, but let's go ahead and go into, is 1, 2, okay. Foot candle at point A. Everybody knows where point A is, right in front of you. The first thing, foot candle at point A, the first thing we need to find, guys, is here. I need to find foot candle from 1, from fixture number 1 at point A. Okay, as you guys know, Q, we're going to call this one, calling it Q. What Q is that? Did I name it? Q, what Q? There's a lot of Q's here. This is that Q1 right here. We have another Q1. So that Q1 here equal big fat fluffy 0. Big fat fluffy 0. Okay, so what does that mean? Means, my friends, when you do your calculation, your foot candle for 1 equal 0.88 times, oh yeah, we need to go, what's the, from fig, what was the fig again? 5.3 page 50. Thank you. Identical. I'm going to do it just, which is 949. 949. 949 lumens. You really don't need to even do that. So then you plug 949, multiply it by cosine big fat fluffy 0 to the power 3 divided by 10 to the power 2. And gentlemen, when you do that, you're going to end up with 8.3. This one will be 8.35 equal 8.35. 8.35. Can you guys write yourself a note? You actually did not need to do this. You could have, I'm going to write a note, I just did it because it's identical to fixture 2 at point fixture number 2 at point B, right? You can write yourself a note. That's, yes, sir.
So,
But
you were going to do it from point 2 to point A. Just be, again, 45-degree angle.
you got it.
But then if you wanted to do it from 3 to A,
Yeah, you have to do the math.
I think I did it as 65.
Yep, you got it. You got it. You're right on the money. Right on the money. Okay, so you guys did not need to do this, right? Because of symmetrical. You did not need to do that. Okay, now from fixture number 1. So we did that one. So that's a fixture from the second thing I'm going to do here. So that's the second one here. is from fixture number 2 at point A. From 2 to A, guys, here's what you're looking at, just to give you an idea. From 2 to A, can you guys see that? From 2 to A, from 2 to A. This is identical to 1 to B. Math, does it make sense? Identical to 1 point, fixture 1 at point B, identical. So you can go ahead and do the math, or, so I'm gonna go directly, guys, for this one. I'm doing it one more time just because of the exercise, so you really don't have to do that. So we're gonna do, so this is fixture 2. I'm gonna call this one Q2. You do the math, 10, let's take the cosine of that baby. Same thing like we did. Tan Q2 equal 10 over 10 equal 1. And tan inverse 1 equal 45 degree. Probably you guys could have figured that out because of identical. The foot candle, my friends, then equal 0.88. Multiply this one by 1039 times cosine 45 to the power 3. Divide everything by 10 to the power 2. Gentlemen, you will get exactly the same like you got 3.23. Can you guys see that? Why it's symmetrical? You do not need to do this calculation. You could say it's symmetrical, Chad, to there will be to 1 at to 2 at B, from 1 at, so from 2 to A is symmetrical to 1 at B. Any comments, guys? Any questions? Comments, questions? If I put this in a test, would you guys be able to do it? Yeah? Cool. So yes, no, good. Everybody can see the symmetrical on the test. You don't have to do that one. If you've done it before for the first fixtures, just say symmetrical and put the answer for it for me. Okay, so that's fixture 2. The last fixture, guys, is contribution from fixture 3 at point A. If you look at the fixture 3 at point A, guys, right in here, now we are looking at triangle that going from 3 to A to C. Can you guys see this triangle? I will remind you 10 plus 10 is 20 here and 10 here. That's very important in calculating the angle, this angle 3, Q3. Everybody can see, right? You guys are good with trig, so go all the way. So that's how the triangle looks like, guys. Here's fixture A, 1, 2, 3. Here's point A, 10, 10. That'll give you 20, 10. So I need to go find my 10. So long story short, tan Q3 equal 10 over 20, which give you 0.5. Which give you 0.5, my friends. And then tan inverse 1, tan inverse, not 1, Chad. Tan inverse 0.5. Let's do the, oh, I'm sorry. So tan is the opposite over the adjacent, Chad. Not the opposite over the adjacent, not the adjacent over the opposite. Yeah, here's the angle. The opposite is this. I did the opposite. The opposite is here, 20 over 10. So that'll give you a 2, right? And then from here, gentlemen, I just did it the other way. Tan inverse 2 equal, if you guys do your calculator, 63 degree. Any comments, any questions about finding the tan inverse? Tan inverse. Tan is the opposite of the angle over the adjacent to that angle. Okay? Now, Aram, the rest is history. When you find this, you're going to go from 63, then you're going to go 63 degree. Take this one to Fig 5.3, page 50. 5.3, page 50. What would that get you? 53. Now, Adam, we don't have 53. What do? You don't have 53. I mean, you don't have 63. What do you guys do? Well, the proper way is to do interpolation. I don't want you guys to do interpolation because it's not worth it at this time because we use the software for it. You go to the closest. The closest for 63 is 165. So everybody can see that. So I'm going to say here we're going to go to 65 degree. And from there, my friends, what was that number? 780 lumens. That's good enough for us. 780 lumens. Gentlemen, then the foot candle, the last thing you need to do, foot candle 3, you're going to add them up, equal 0.88 times 780 times cosine 63 raised to the power 3 divide by 10 square. And when you do all this math, that will get you a healthy 0.64. Can you guys see, Derek, can you see that's becoming very small because it's far away from the fixture? The foot candle is becoming really small because it's way far away from the fixture. Okay, so let me summarize, guys. We did the calculation at point A. I'm going to go highlight what we came up with. We came up with this value from fixture 1. We came up with this value from fixture 2. And we came up with this value, gentlemen, from fixture 3. Now, Matt, what are you going to do? 3 foot candles from 3 different fixtures at the same point, Brian. What do you need to do? Add them up. So the next, any question, guys, before I move to the next step? Mistake number 1, Adam, when people did it on the test is they don't know how to use the sine and cosine. Make sure you know how to use your sine and cosine in your calculator. They don't know how to cube a number. Make sure you look at your calculator and know how to cube a number. Multiply the number by itself 3 times. If you don't know where the function cube, you just take the number, slam it by itself 3 times. Or there's a function in scientific calculator that can get you the total. Okay, gentlemen. Then the last thing we need to do here is total foot candle at point A. Total foot candle at point A equal foot candle 1 plus foot candle 2 plus foot candle 3. And gentlemen, that will give you 8.35 plus 3.23 plus 0.64. And if you do your math right, if I did my math right, that will get you this amount. 12.22 foot candle total from contribution from the 3 fixtures. Now, Matt, I hope that will make you fully appreciate what visual does for you. When you push the button and bam, you get the foot candle at every single point. When they do it outside, guys, they do it 10 by 10 feet. At every 10 by 10 feet, they give a number. You can adjust that one. Or inside, they do it at 2 by 2 feet. Every 2 by 2 feet, wherever the 2 by 2 cross each other, they do a calculation. So that's the, at point A, we're going to have 12.22, right? At point B was 14.87. Makes sense. Point B, guys, right in the middle of all these fixtures. Can somebody predict, please, can somebody predict what's going to happen at point C? Do I need to do the calculation at point C, guys? One more time. Now I got point A, point B. Look at C. Let's go back and look at C. Do you guys agree with me? The calculation, the foot candle at point A is identical to the foot candle at point C, right? Those are symmetrical. Otherwise, go ahead and do the calculation from 3 to C, from 2 to C, and from 1 to C, right? It's exactly the same as the calculation from 1 to A, 2 to A, and 3 to A. Be my guest, go ahead and basically repeat everything that we have done so far. But because of symmetrical, you don't have to. Here's how I can screw you guys up a little bit, and I can make this number here instead of 10. Look what? 15. Now you screwed up the symmetrical. There is no longer symmetrical. These triangles no longer symmetrical. Well, for this example, gentlemen, we're not going to mess around with you. So I'm going to go and write right here, total foot candle at point C as 12.22 identical symmetrical triangles. Symmetrical triangles, guys. Symmetrical triangles. Same calculation. Yes, sir.
So when we're doing, I calculated what gave us 48 over here times the lumens times the cosine angle to the third or whatever. And then we're doing that all over, and in this example it's 10 squared. And 10 squared, that is the distance squared.
No, that will be the height. There are two formulas. The formula that has that here, that one, it's a mounting height, not the distance. The distance is this. It's the mounting height. If you use the distance, the formula will be different. There are two formulas. The easier one, guys, is the one that has a mounting height. Why? Because we always know what the mounting height is. But if you want to find the distance between 3 and B, you can. This is hypotenuse. So what they do is they manipulate using trig. They manipulate the formula to get you a form of the formula using the mounting height instead of a distance. Okay.
Can we not have that second frame on the sheet?
The second one, we're doing it for vertical calculation. You hold your horses. Everything that we've done right now, don't look at the second one. I should have read you. The second one is for vertical calculation. You know what the vertical is? We're doing this way. Horizontal, we're doing it this way, yes, sir.
Okay, and the only part that I was confused about was when you did the angle Q3, when you did adjacent over opposite.
Up.
It was tan, and it would be opposite over adjacent.
I at the beginning I made a mistake, but I corrected it. I put the opposite over the adjacent. Here, let me go to Q3, right? That's the one that you're talking about, right?
Yeah.
Okay. Here's the angle that I'm looking at. Where's the opposite? This side is the opposite.
Yeah. Come on.
So 10 plus 10 equal 20,
Yep.
right? Over
Yeah.
10. Okay. No, I wrote it wrong at the
Yeah.
beginning.
No, I was just looking at that. I was thinking the opposite way. 10 was the opposite side. So.
Yeah. There are two 10s here, which is for a total 20 and one 10 here.
Yeah. No, I was just thinking 2, 3, the center there was still the opposite.
Okay. Any comments, guys? Any questions? Any comments? Any questions? So Adam, on your test tomorrow, not tomorrow, next week, guys, it will be a problem identical to this. And you are to find the foot candle, the total foot candle at point A, B, and C. Identical. You will be using, guys, the same fig. Without the fig, the isometric fig that we talked about, the photometric data sheet, you cannot solve this problem, right? Because the fixture, guys, will give different lumens at different angle. Can you guys see that? Fixture here, here's a fixture. At this angle, it will give different lumens at different angles. Different lumens at different angles. Any comments, any questions before I move into the vertical walls? All what we have done, Brian and Adam, my friend, is here's a parking lot outside, not inside. I put a pole here and put a lighting fixture here, and I did a calculation at a couple of points around that fixture. That's what I did right here. So instead of, in this example, I have 3 of them. 1, 2, 3. Outside, no walls, no ceiling, no reflected light. And I'm doing my calculation, guys, at what? What we call it the horizontal foot candle calculation. Everybody knows what the horizontal is right here. Horizontal. Now the next problem that you guys are we're going to be doing is we're going to do vertical. So watch me, guys. Here's the horizontal foot calculation. Look what I'm going to do. I'm going to go do this and have the fixture standing right here and shining at a surface. Vertical. This is called vertical foot candle calculation. Adam, we did this one yesterday with you, right? Wall wash light. Now we're going to do a wall wash light. Why do we need to do this? Wall wash is a good point. How about billboard? If you want to lit a billboard, you put a light right here. If it's not a lit billboard, if you want to shine a light on a billboard or what's not, you put a light right here and you shine it right at it, right? You need to find the foot candle at this billboard. So vertical surface foot candle calculation is very important, guys. Now, of course, not as important as horizontal, because most of us we work in the horizontal world, we don't climb the walls. So before I move into vertical, the calculation that I did, Karen, is a lighting fixture, 3 of them on a surface, and I picked 3 points, and I calculated the foot candle contribution from every fixture at every one of these 3 points. I could have picked 100 points and make you guys sit here until tomorrow morning doing the calculation. Would you rebel against me? But we're gonna go only 3. Now, if I wanna, Matt, if I ask you to go find the calculation right here at this point, would you be able to? No problem. Tell me, Chad, how far away do you want this point from the fixture? How about 4 feet? If I give you this is 4 feet away from this fixture, go do the calculation at point A, B, C, D. Point D, which is 4 feet away from this fixture, so that will make it then 6 feet away from this fixture, and do the calculation. Yes, should be able to. It takes longer, more angles to play with, but it will do the same calculation. Any comments, any questions? Shall I switch to the vertical calculation, guys? Here's my horizontal, doing calc. Let's go now, flip it and do calc in the vertical. I can't emphasize, so you don't get confused. What we have done so far is we're doing foot candle calculation on the horizontal. Next example I'm gonna do, guys, for you, I'm gonna flip that surface, or put it this way, for example. Here you go, you put your light here, and you're shining light. I'm interested on the vertical wall. Cool? Everybody understand where we're going next? Vertical? Do I keep repeating myself like a grandma or grandpa? I found myself. Okay, so let's go do this example, guys. Okay, so we got that one easy. So, like I said, on your test, guys, there will be a vertical and a horizontal. Would you be able to do the horizontal piece of cake? Here's the vertical. You guys have this graphic in front of you. You need a new formula for the vertical. Did you understand? Because of the geometry and the trig relationship between the angles and the distance and the height, you're going to be using a different angle. Here's the formula that we're going to be using, guys. Foot candle V for vertical equal candela power sine Q, sine and not cosine, sine Q, because now we're shooting light this way, not this way. Sine Q divided by D, the distance. Sine Q divided by D, the distance. Can I have thumbs up, Chad? It's a different formula for the vertical. So on the test, guys, write them down, bring them with you. So if you're doing vertical, use this formula. Cool? Okay. What do we have here? What we have is the following, guys. I have a floodlight right in the front of a board that I want to lit. And that floodlight is mounted at 10 foot. Can you guys say that? 10 feet. It's mounted at 10 feet and it's set back 4 feet away from the wall. One more time. I'm the light, here's the wall, 10 foot, 4 feet set back. Can you guys see it's a 4 feet set back, 10 foot high. And your friend Chad is asking you to find the foot candle on this vertical wall at 2 points only. I can ask you to do them at 100 points. It just becomes repetitive. At point number 1, gentlemen and ladies, and point number 2. Point number 1 and point number 2. It's so important that the geometry, guys, when I give you this, you have to go draw things, because you need the angle. You need to find the angles and what's not. Okay, so 2 things you need. Number 1, you need a formula. You're looking at it. And number 2, you need a graphic so you can do the trig calculation. Any comments, guys, about the graphic, the example that you have? I have a lighting fixture, the same lighting fixture that we've been using, at a 10 foot height, set back 4 feet from a wall. And I would like you guys to do the calculation first at point 1, which is straight from the fixture, and at point 2, which is halfway through. Can you guys see halfway through in the middle of the in the middle. One, here's what calculation right here, guys. Calculation number one right here. Calculation number two is right in the middle of the wall. Here, middle of the wall. Different angles. Can you guys assure me that you know what the problem is that we're trying to solve? Yes? Brian? Okay. All right, let's go do it. So the first thing you need to do, guys, is we're going to do it at point A. So let's go ahead and let's do at point at point one. At point one. At point one, guys, Q1. Can you guys see Q1 right here? Everybody can see Q1 with the vertical. Q1 equal 90. Right? Q1 equal 90. Then you take the 90 degree, take this baby to Fig 5.3, page 50. If you take it there, you find the candela power at 90 is 8 candela power. Did I do it right? 8 lumens. Is that at 90? Yep. Okay, so not a whole lot. 8. Can you guys see that? 8 lumens. Everybody can see that? 8 lumens. Okay. One more time. The angle is 90. You take the 90 to this fig, you got yourself an 8 lumens. Okay. Let's go ahead and do the foot candle. Foot candle vertical. It has to be vertical. Equal. I need to use the same the guard. My guard was 0.88. Multiply this one by 8. Multiply by sine, not cosine, sine 90. And divide this one by the distance. What's the distance? Can you guys see D is the distance here, D1? Everybody can see D1 is the distance here. D1 is 4. Divide by 4. Ladies and gentlemen, if you do that, you got yourself a healthy 0.44 foot candle. Any comments, any questions? Any comments, any questions? 4, thank you, to the power 2, thank you. 4 to the power 2, yep, absolutely. Just forgot the 2. Thank you. One of us is awake. We don't cube it. It's a different formula. Here's the formula that you're using. Completely different. Remember, we're doing vertical now. We switched to a different formula. Any comments, guys? Any questions? Comments, questions?
You didn't tell us question for all the props. Is it using 0.88 on one side? Or is it
This is a guard factor that you're given. I'm giving you a guard factor right here. It's not dumb here. Can you see that? 0.88. That's like when you have a light outside, you put a guard to protect it. That guard will limit the amount of light that comes out of it to protect it, so that by how much they'll limit it down to 0.88. That's what the guard factor is. It's like a maintenance. Think of it as your maintenance factor that we use again. Okay, so let's go back here. Sorry. Here we go. Any comments, guys? Any questions about this? Derek, I see a question right in your right eye.
No, I was just trying to see. Q1 is supposed to be that whole angle right there.
The Q, yep, right here, from here all the way to
Okay,
here,
alright.
which is 90 degrees, right?
Yeah.
Good. Any other questions? So that's the calculation at point 1. Very easy. The calculation at point 1. At point 1. So let's go do calculation at point 2, will ya? So I'm going to go do the calculation, guys, at point 2. Foot candle at point number 2. At point number 2, guys, here's the angle. Here's Q2. I have 5. I'm going to remind you guys, this is the triangle that's coming out of here. Can you guys see that? At point 2, Do you see that red triangle? Here's point 2 here. I have 5 because it's halfway through. 5, 4, and here's the hypotenuse. 5, 4. Everybody can see where the 5, 4 came from? So important to find the angle. And here's the Q2. Everybody can see where Q2, that little one here, Q2. Okay, let's go do that. So from 5, 2, you're going to find a couple of things. Okay, so let's get directly into this. So we need to, so we at point 2, so tan Q, then tan, oops, let's use a different color here. So at point 2, we need to find tan Q2. Here's Q2, guys. The tan is opposite over the adjacent. So my tan Q2 equal 4 over 5. Everybody can see the 4 over 5? My 4 over 5 equal, so that's my 4 over 5 is my triangle. Then, so we got my tan, which is 0.8. Now the next step that you need to do, guys, is we need to find tan inverse. So here's one, tan inverse Q2, tan inverse 0.8 equal, which is the angle that has a tan of 0.8. That's what the tan inverse is. If you guys tan inverse it, you'll get you 39 degree, angle of 39 degree. Cool? Angle of 39 degree. Matt, any comments, questions? Make sense? 39 degree. Okay, now from 39, now the last thing you need to do is you take the 39 degree, you're going to take this one to Fig 5.3 page 50, and you're going to find the candela power for this baby is 1059. Adam, since we don't have 39, we're going to go to the closest to it, which is 35. I'm going to go directly to 35. Since there is no 39 in the sheet, get to the closest. The closest, up or down, doesn't matter. Just for the sake of the calculation. In real life, Karen, you have to do interpolation. Not worth to go there. So get that one. Everybody can see that one. So that's my lumen. That's how much lumen is coming at this angle. Cool? Any comments, guys? Any questions? Comments, questions? Are we done? So what do you need to do next? What do we need to do next? So we found the angle, and we found the lumens. What else do you need? D, the distance. So we need to find the distance. Let's go find the distance. D, you can see where D is. Here's D. Pythagorean theory said you square the two sides, add them up, square each side, add it to the other side square, take the square root of it, you find D. So we need to find D. Then D equal, from Pythagorean theory, 5 squared plus 4 squared. And if you guys do your math on that one, 5 squared equal 6.4, thank you, feet, 6.4 feet. Gentlemen, the last thing that we need to do is basically find the foot candle vertical at this point. Let's start plugging him in. We're going to plug the 0.88, the guard factor, multiplied by cosine, oh, not cosine, Chad. I keep saying cosine. Sine, which angle is that one? This is sine 39. Use the 39, guys. Sine the 39 degree, because that's the actual angle. Divided by, Kieran, by the distance squared, 6.4 raised to the power 2. Thank you. And I need to go to my candela power, which is 1059, multiplied by sine, did they say 39? Yep, 39. Cool? Sine 39. Then we're going to go find the math. Gentlemen, when you're done, what do you come up with? Thank you. 14.3 foot candle. Vertical foot candle. So now, right here, guys, here's my fixture. Right at the center of that billboard or wall, you're going to have 14.3 foot candle. I'm going to add one more point for you so we can exercise it. One more point. Just hold your horses. One more point. It only takes a second to do a point. You guys are just getting rushing yourself and rushing me. So any comments, any questions, guys? So at point 2, this is what you get. I'm going to go add one more point to see it right here. Look how easy I'm going to make it. I want to put point 3, guys, right here. Can you see that point here, right here? Oops. I'm going to call this is point 3, right here. And I want to draw a triangle. I don't know if you guys can see that coming all the way to here. That's my triangle. Okay? So let's go find that point. Everybody can see where point 3, right at the bottom of that billboard. Right at the bottom. I want to see how much we can get right at the bottom of that. Okay, I haven't done the calculation, so grab your calculator. I don't have this one. So let's go do that one. Any question, guys? Everybody got that one? Am I going too fast, too slow? Okay, so let's go and find, I'm going to say foot candle at point 3. At point 3, the triangle, guys, that this will make, oops, actually, it's make it more realistic triangle. So I think I need a graphic class in graphics here. Here you go. It was smaller here, so does it really matter? There you go, and here's my triangle. Okay, this is Q3. This was 10 feet, and this was 4 feet. Right. This is my point 3 right here. Right. This is a triangle. Okay, so let's go ahead. Why it's important, guys? Because we need to find, and here's the D, the distance. Let's go first find the tan, guys. Tan Q3 equal opposite 4 over adjacent 10. So, and then I need somebody, so 4 over 10. So that will give you a 0.4. And then Adam, can you give me what's the tan inverse 0.4 equal 21.80, right? Anybody confirm 2? Okay, good. This is the degree of that baby. Okay, 21.8. Then we need to take my baby, which is 21.8 degree, take it to Fig 5.3, page 50. What's the closest to it, Adam? 21. Okay, so the closest to that baby is 25. The closest to it is a 25 degree, and that will give me 1090, right, Adam? Lumens. Okay, perfect. So I got the lumens. Gentlemen. The second thing I need to do is the distance. I need D. D equal square root of 4 squared plus 10 squared. Who's my favorite? Is going to give me the answer. Square the 4, square the 10. How much? 10.77, 10.8 feet. I need the second. Can I have a second? Second? Third? Okay. Am I doubting Thomas here, Derek, or what, man? I need a second at least. It's easier before you start plugging numbers. Okay, 10.8, thank you. And the last thing, gentlemen, that you need to do is plugging these numbers all together. Foot candle equal 0.88 times sine, what's the angle? 21.8 degree. I need to multiply by the, first by the lumens, which is 1090 times sine 21.8. And I'm going to divide everything by, what's the distance again? 10.8 squared. Gentlemen, need two gentlemen to agree on a number. 2.9. Do I have a second? Second.
3.05.
Oh, three different answers. Did we take 0.88 times 1 or 1090 sine?
I didn't do, I just did sine 21, I didn't do 0.8.
Okay. What was yours?
2.9.
2.9?
Yeah, 3.05.
3.07.
But depends on what hers is rounding up to how many decimal places hers goes to.
Okay, what was yours, guys?
3.0539.
3.05. 3.1. 3.1 it is.
So mine is really
3.1. Okay? Is that cool enough? Close enough? 3.1. So the foot candle right at the bottom of the billboard, guys, right at the bottom of the billboard here, 3.5. In the middle of it, it was 14, and right at the top, right, it was less. What was it? Whatever that number is. Any comments, any questions, my friends? What you guys have done with your friend Chad is you have done foot candle calculation by hand outdoor from a direct light, no reflection. Don't care about reflection. On a horizontal surface like this, as well as on a vertical surface. Horizontal surface and a vertical surface. Adam, and I think I did it with you, and I don't know if I did it with you. We did it all together yesterday. Do you guys remember how we did the wall wash lights yesterday, and we grabbed that wall? That's exactly what this calculation is supposed to do except visual was much, much easier, right? Just pick that wall, assign a calculation zone on it, put a special light that actually throw light. It has to be oriented toward throwing light at the wall, and hit calculate, and off it goes with your point-to-point calculation as well as the average. Okay, so to summarize, my friends, before I let you go, so what we have done, guys, today, we did foot candle calculation on a surface. We picked 3 points, 0.1 at the top, 0.3 at the bottom, and 0.2 in the middle of it. And we have in one formula, Adam. And the last one we did, or the first one we did, is we have 3 holes, 10 foot each, with lights at the top of them, 10 watt metal halide in a parking lot, placed 10 foot each apart. And we did the calculation, the contribution foot candle, horizontal foot candle, at the 3 point A, point B, and point C. If I get this in the test, guys, would you be able to ace it? Piece of cake? What do you think, Matt? Cool? So let me see if I forgot anything in that chat. So that's this chapter, just the calculation. You guys can go read that. Now, in page, I don't know if you guys can see, page 55, they're putting a point 3 here far away, guys. Then it becomes a trig, playing with trig. I don't know if you guys can see example in page Fig 5.4. They're giving you a point not in line with the fixture. Look at this math. Here's the fixture. If at any point along the line of this fixture, easy to do the math. If you put it right here, then you have to do a lot of trig. I'm not going to test you on that one, guys. You basically, if you have 2 fixtures, if they put the fixture, if you find the point right on the line where the fixtures are located, exactly like here, then you can see that easy. Now, what happened if the fixture is here, and I want you to find a point right in here? So you have to do a few calculations. Ouch. You have to do a few calculations. Okay. So be aware that this fig is doing more trig a little bit to get what you want. That's all I have for you guys. Any comments, any questions? So with this, that will wrap up 5 chapters, guys, of lighting. I hope that'll give you kind of a taste of what we have done. next week when we start lighting, guys, again, we will talk a little bit more about outside light, floodlight, and then we'll get inside and we start talking about doing calculation point to point and average calculation indoor, which is, we're going to be using the same, almost the same formulas with some modification. Okay, thank you.